This is an important message for my first year seminar students for the lesson that we will be doing today. You see, we've talked a lot lately about how to make decisions and look at the data and use the data to try to inform your decisions. The hard part is often you have a lot of noise which masks the signal that you're trying to hear, which is why when I play this video in class, I plan to play another video with something like rock music super loud over it, so that right now you're all watching my antics, but you can't actually hear a single thing that I'm saying. The point being, when you gather data, for example, I want to know what will getting a good night's sleep do for me. And then you gather data, but you get noise. You try it once, you get a good night's sleep, but that night there's a dog barking or you have a lot on your mind, and so you find that getting a good night's sleep didn't do much for you. Well, there's a lot of noise there. Can you really tell what the signal being the effect of a good night's sleep, what that signal is doing? So we're going to find out there's two possible answers here. One is you can reduce the noise. And we will spend a lot of time talking about that. We're going to talk about how do you find bias, how do you account for those extra variables. Sometimes you get rid of them, sometimes you control them, and sometimes all you have to do is measure them. But number two is you can increase the message volume, which would happen if I yelled, but I'm trying to keep the volume steady because the example in class requires the other music to be masking over the sound. Point is, getting more signal is getting more data. And that is a very important tool. That's what our goal today is to talk about. How much data do you need and how much data will it take before we'll actually be able to detect the signal over the noise?